Okay, hello everyone. So in the previous video, we gave a brief introduction to rational functions. Now in this video, we will find the domain and range of rational functions. Now as you will see as we proceed, there will be different methods depending on the given function. Okay, so let's start with f of x is equal to 3 over x minus 5. So as you already know, what we need to watch out for here is the values that make the denominator 0. So how can we find those? So let's just equate our denominator to 0 and then solve for x. So if we add 5 to both sides, we will get x is equal to 5. Okay, so what does this mean? So if x is equal to 5, then our denominator here will be 0. So we can't have that, right? Okay, so our domain, as a result, our domain is as x such that x is an element of real numbers and then x is not equal to 5. Okay, so there are many ways how to write the domain, but I just chose here the set builder notation. Okay, so how do we find the range? So for this particular given, we can use the inverse, okay? Because um, the domain of the inverse of a function is equal to um, its range. Okay, so in other words, if you take the inverse of f of x equal to 3 over x minus 5, so the domain of that inverse will be equal to the range of this particular function. Okay, so let's try to find the inverse. So let's just write f of x as y here. Y is equal to 3 all over x minus 5. So how do we find the inverse? So let's interchange the x and the y first. So x is equal to 3 over y minus 5, right? And then let us solve for y. So how do we solve for y? So by multiplying y minus 5 on both sides, we will get x times y minus 5 is equal to 3. Now we can divide both sides by x, you will then get y minus 5 is equal to 3 over x. Then by adding 5 to both sides, you will get 3 over x plus 5. Okay, so this is now our inverse function. Okay, so let's take a look. So what do we need to watch out for? The denominators again, right? So as you can see here, if our x is 0, then this will be undefined. Okay, so for this inverse function, so let's remember that the domain of this inverse function is equal to the range of this f of x is equal to 3 over x minus 5. So let's just directly say that therefore the range is um, x element real number such that x is not equal to 0. Okay, so this is your range. Okay, so let's now proceed to the next one. So for the next one, we can apply the same methodology. So in order to find the range, okay, I mean in order to find the domain, so let us equate x minus 4 is equal to 0. Then we will find x is equal to 4. So we can then say that the domain of this function is x, such as x element of real numbers, x must not be equal to 4. Okay, very cool. So let's find the range again. So y is equal to x plus 3 all over x minus 4. So let us interchange the x and the y. We have here x is equal to y plus 3 all over y minus 4. Okay, so let's multiply y minus 4 to both sides. X multiplied by y minus 4 is equal to y plus 3. Okay, so we have here xy minus 4x is equal to y plus 3. Okay, so let's add 4x to both sides. So we will get y plus 3 plus 4x. Then subtract y on both sides. Xy minus y is equal to 3 plus 4x. Okay, so what are we going to do next? We're going to factor out our y. Y will be minus 1 is equal to, let's just write for x plus 3. So let's continue this here. So we're consuming a lot of space. So let's divide both sides by x minus 1. We will then get 4x plus 3 all over x minus 1. Okay, so this is our inverse function. Okay, so let's find the domain of this, which will be equal to the range of our original function. Okay, so this is x minus 1. So x minus 1 is equal to 0. That will be x is equal to 1. Okay, therefore the our range is set of x such that x is an element of real numbers, and then x is not equal to 1. Okay, very nice. Now, um, this methodology right here in finding the range, um, we use the inverse, right? We use the inverse of the original function. Now, this method is only applicable if the function is one-to-one. Now, what does one-to-one mean? So let us take a look at the graphs of both of these functions. So we have here f of x equal to 3 over x minus 5, right? So this is the graph of that. So a one-to-one function means that for every value in the domain, there is only one and only one value in the range. Okay? So that is what it means to be one-to-one. So how can we determine if it is one-to-one or not? So one of the tests in determining if a function is one-to-one is to do a vertical line test and a horizontal line test. So the result must be in the vertical line test, only one intersection with the graph. The same with the horizontal line test. So all throughout, there should only be one intersection. So as you can see here, this function is one-to-one because if we make some vertical lines here, it will only intersect the line once, right? So as you can see here, this is looking like a vertical line, but actually it is not. It is approaching an asymptote. So we will discuss asymptotes later. So if we do a horizontal line, it's the same thing. So although this a line near the zero looks like it's parallel with zero, it is actually not. Okay? It's just approaching zero at very infinitely tiny increments, but yeah, it is not parallel with the x-axis at all. Okay, so that's example of a one-to-one function. Let's take a look at the other one. I have here x plus 3 over x minus 4. So do we have that here? So here it is. So the graph is more or less the same. There is just a bit of a scaling that happened and also a bit of a translation, but it's more or less the same. So there is no multiple intersections if you do a vertical line test, as well as if you do a horizontal line test. So those are one-to-one. Okay, so it is different if you say that if a function is not one-to-one, like for example this one. So let's take a look at the graph of this one. So as you can see here, if you do a horizontal line test, it intersects the graph more than once. Okay, so this is not a one-to-one function, so we cannot use that method that we just used in finding the range. But in finding the domain, we can definitely find the domain here. Okay, so in order to find the domain, so how do we do that again? We need to be watchful of what makes the denominator 0, right? So let's do that. So 2x squared minus 11x plus 12 is equal to 0. So let's factor this out. So we can factor this out to be 2x minus 3 and then x minus 4. So that will be 0. So let's then use the zero product property. So we can add 3 to both sides. X is equal to 3 over 2. Okay, for here, we have the x minus 4 is equal to 0 and then x is equal to 4. Okay, so these are the values that make this function undefined. So therefore the domain domain is set of all x such that x is an element of real number, then x is not equal to 3 halves, and then x is not equal to 4. Okay, so that is our domain. Now for the range, so again, we cannot use the inverse, right? So what we're going to do is we're going to plot the graph. So as you can see, we've already done that. So we have it here. So as you can see, if you evaluate the graph, so by the way, this is Desmos. You can access this online tool for graphing. It's a really good tool. So if you evaluate the graph, so it is the range ranges from a negative infinity to positive infinity. So therefore, we'll just write here. So therefore, the range is the set of all real numbers. Set of all real numbers. Okay. So that's it for finding the domain and range of rational functions. Okay, thank you for watching, and I hope you learned something new here. And see you in the next videos.